So in today's class, we are going to discuss a new library called as Numpy. Okay. So Numpy is nothing but a numerical Python. So Numpy full form is numerical Python. So just we are going to discuss the next library called as Numpy. Okay, it is a open source Python library. So open source Python library means where we are it is completely once again free, which is used to do the mathematical and scientific programming. Okay, for mathematical and scientific programming, we are going to use the Numpy. So Numpy works with an arrays by using the arrays. So whatever the data you are having, you have to convert first that one to an array. Later on the array only we can do. Sir, now simple example. Let me explain in a very simple way, simplistic way. Now, if Numpy is there, what happens? Without Numpy, what happens? Assume there is no Numpy. Okay, without Numpy and with Numpy, right? Now, without Numpy and with Numpy. First, let us discuss without Numpy. Without Numpy is whatever we have discussed till now, that is core Python. Assume that I am having list 1. List 1 is equal to 1, 2, 3. List 2 is equal to 4, 5, 6. I am having two lists. And if I use L1 plus L2, I am going to get output as 1, 2, 3 and 4, 5, 6, which is going to be extend. It is similar kind of extend, and it is also called as list concatenation. But I don't want the output like this. My requirement is not this one. My requirement is in a different way. What is my requirement is 1 plus 4, 1 plus 4 and 2 plus 5 and 3 plus 6. I want to get an output like this 5, 7 and 9. Can you please write a program which gives the output of this one? Guys, please write a program in your notes which gives the output this one. The first position of first list has to be added with the first position of the second list. Now, for I in range of 0 to 3 elements are there. So I'm going to consider 0, 1, 2, 3, 0 to 3, range of 3. That is 0, 1, 2. I'm going to get. Now nothing but L3. I'm going to create a new one list, empty list like this. L of 0 or L of I. L of I is equal to L1 of I plus L2 of I. Now I value is 0. 0 means L1 of 0 is 1 plus L2 of I means L2 of 0 is 4. These both will be added and L of I will be there. Now this is going to be stored in a variable called as not L of I. It is going to be stored in a variable called as A. Now what I'm going to do is list dot L dot append of A. Just I'm going to take list dot append of A and print L. This is the code, right? Where I'm going to take with respect to the index numbers like 0, 1, 2. First 0 index number will be taken in the both the index numbers of 0 will be considered, and it is going to add, and it is going to create with respect to an append function, and in that append function it is going to add that one. So first index number of 0 will be taken, L1 of 0 plus L1 of L2 of 0, that is 1 plus 4, which is equal to 5, and this will be added with 5, followed by 1. I is equal to 1 now. 1 is equal to L1 of 1 is nothing but 2. L2 of 1 is nothing but 5. 2 plus 5, 7. 7 will be added here, appended with 7. Followed by 9. 9 will be appended. So this is the program. So for this, we are going to use the program, this one. This is the program for adding the two list. This is the program for adding two list element wise. Now the same thing. L1 is equal to 1, 2, 3 was given. L2 is equal to 4, 5, 6 was given. Okay. Now what I'm going to do is L1 plus L2. Instead of adding like this, first I'm going to convert this L1 to an array. Array of L1 plus array of L2. If I write like this This output is 5, 7, sorry, 5, 7 and 9. This is the output. In the NumPy, if you write just array of L1 plus array of L2, it is going to generate the output like this. The only difference between these two is this one. Now, here the question is with respect to how it is generating and how it is working. The array of L1 plus array of L2, how it is working means array is nothing but a concept of with respect to for loop. For plus list is called as NumPy. For plus list, both of them is called as NumPy. By combining all this in the back end of array, the same thing is there. For loop with append, for loop with append, for loop with append. For loop plus append is called as an array. For loop with append is called as an array. Now, just here, just observe this one. Here, if you go with A is equal to this example, simple example, A is equal to 1, 2, 3, 4, 5, list of 1, 2, 3, 4, 5, print A. Print A means list of 1, 2, 3, 4, 5 and print type of A. What is type of A means list type. You are going to get list of 1, 2, 3, 4, 5 and the output of type of A means list type. It is a list data type. Fine. Now you are going to take the NumPy. You are going to import the NumPy as NP. Wherever you have to use NumPy, you are using just a shortcut of NP. You are not going to use complete word of NumPy. You are just using, yesterday I have told you, right? Import srk as M. Similar way here also. Now in the srk.add, how we have worked on this function. Similarly in the NumPy also, in the numpy.py file, multiple functions are there. Within the numpy.py, multiple functions are there. We have to work over the functions. In that, one of the function is called as numpy.array is the one of the function. Just it is opening the numpy module. Within that numpy module, it is going to work on the array function. This array function was there inside the numpy module. Now this numpy, what I am going to import is np. So every time I no need to use numpy, np.array. Simply I can use np.array. Now, just see here, first import numpy as np, and if you see the version, this is the latest version which I am working. Now, what is meant by numpy array? Numpy array means, see here, A is equal to 1, 2, 3, 4. Whatever the A is equal to 1, 2, 3, 4, the same code. I'm writing, see this one, same to same. This is, earlier it is a list. Now this one, I'm going to convert to np.array of A. np.array of A, and I'm asking print this one means, it is getting printed like this. Now, what is the difference between this one and this one means, here you are going to get the list of elements without comma. Here there is a comma that is called as list object. This is called as array object. Array means everything is considered as one item. Entirely it is considered as one item. Here each of them is considered as each one item means, here entire array is considered as one item. Now here, if you ask this print, whatever the print you are asking, okay, if you ask like this, the variable means it is going to print array of. Array of like this means with respect to, that is numpy array. If you ask print of np.a underscore a means it is going to print like this. If you use without print option means it is going to print like this. Both are same only. And if you ask what is the type means it is a numpy array. It is not a list. So in the array how the array was created means the array were created based on the for loop. In the backend, I told you now, within the numpy, a list of functions are there. Out of functions, one of the function is array. This function, how this function was created means whatever the input you are going to give, it has to be appended for each of them into one. In the backend, it is having for loop with append of each individual value. Just it is appending of each and every individual value into a single item. That is nothing but array. Right? So now here in the print option, in the print option output variable only you can see like this. But the matter is, this one is an array, this is a list. How it is going to be displayed means like this it is going to be displayed. Because numpy was created based on the list. It is not going to work for the tuple or sets or others. It is going to work only for the list. Right? This library was designed for the list because mostly everything we are going to generate in the list. Sir, if I want to work on the tuple, sir, first tuple you convert to list, then you apply the array. Right? Now, here creating an array, creating numpy arrays from using a list. How to create means in the numpy arrays we can create with n dimension. So here if you observe this one, used for working with an arrays. All the NumPy operations works with an array only. First you have to convert to array, then only you can apply the NumPy. In the NumPy, any operation or any function you want to apply, anything you want to do means everything has to be done based on the arrays only. Without converting array, you can't apply. Without converting array, directly you have to take the list and you have to apply your core Python separately. Take the list and apply the core Python directly. But when you are using the array, when you have converted the array, work on the NumPy. So it is used to make with respect to simple mathematical and scientific programming. The entire max using the Python, if you want to do the max means they are going to use the library called as NumPy. So in this, the linear algebra is there, calculus is there, everything is there apart from the statistics. Statistics is not there in the NumPy. Statistics, SciPy, scientific Python, that is different. NumPy means numerical Python, right? Now, in Python, we have the list that which will serve the purpose of arrays. Similar kind of the same thing which are in the Python is list, but they are slow to process. And we have to write the lengthy code for that. The lengthy code has brought us a shortcut called as NumPy arrays. This NumPy aims to provide an array object that is 50 times faster than the normal Python list. When compared to them, the working or with respect to processing or the code, everything 50 times it is better than the normal list when compared to, right? So it is NumPy is an incredible library to perform the max operation, mathematical operations. For example, if you want to calculate the depth of A, that is matrices, or if you want to apply the linear regression, some kind of linear algebra, all this will be applied using the NumPy easily, right? And it is optimized with respect to the whatever the CPUs we are having, latest CPUs, it is optimized along to with that, and where we can easily work on the linear algebra, Fourier transforms and matrices. Majorly, this statistics we are not going to use NumPy. Generally, most of the statistics are not available in the NumPy. Statistics will be available in the SciPy or stats models. These are the other two libraries are there separately for statistics. Okay. Now, NumPy is a n-dimensional array. It is not with one-dimensional. Whatever you have seen just now, it is a one-dimensional. One-dimensional means you are having only on one axis, that is x-axis. But you can create simultaneously with multiple axes, that is n-dimensional. Okay, n-dimensional array. So, for example, let us take this kind, one line. If you draw a line, means this is called as one dimension. If you take one line like this and one line like this, then it is called as two-dimensional. Now, if you take the same thing with respect to like this, and if you draw something like this, then it is called as three-dimensional. For example, let us take a simple example. Whatever you are seeing the board, offline students are seeing the board, whereas online students are seeing the laptop or desktop, whatever it is. In front of whatever the screen is there, the screen is a two-dimensional one because it is having the length and breadth, right? Now, if you go with respect to this classroom, offline students classroom and online students, whatever the room they are sitting in that room where they are having three-dimensional space. The three dimensions are length, breadth, and height. Okay, whatever you are seeing in front of you, this one, the depth is there na, room depth will be there na, that is the third dimension. In front of you, whatever the wall is there, that is two-dimensional wall. With respect to the length and breadth, the height is the second dimension. Third dimension is depth of the room, is the third dimension. This room is a three-dimensional one. So best example for three-dimensional is cube. Everyone plays the Rubik's cube, right? The Rubik's cube where we are having the cube, it is a three-dimensional. Then how we are going to represent the same thing is by using some diagram like this, where we are having with respect to cube or cuboid, something we are going to use, and this is a three-dimensional. Now you can see with respect to one-dimensional, some kind of one-dimensionals. You can see the two-dimensionals. You can see the three-dimensionals. Can you tell me any object with four dimensionals which you can see? Any fourth dimension object? Can you see? If you are able to see any fourth dimension, means first you have to go to the eye hospital immediately. Okay. The hexagon or whatever the pentagon or whatever it is, the shape also two-dimensional only. It is represented on the two-dimensional. In the entire universe, with the human eye, we can't see more than three dimensions. Right? This is also one of the interview question, you know. In the interview, they'll ask this one. Though it is silly also, in the interview they'll ask. Because some students will create the fourth dimension, such square is there. Na? Square is called as 4 dimensions for them. If someone says square, or someone says with respect to each line as one dimension, something they say like this, na, immediately we'll understand this person. No need to ask further questions also. From this one only we can conclude that, okay, high level knowledge is there, we can't sustain it. Okay, this kind of high level knowledge people we can't sustain, so simply we can send them out, right? Now, so here we can create with respect to multiple dimensions. Okay, in the n-dimensional array, we can create with respect to multiple dimensions. For example, universe, they will say with n-dimensional space, but you can't see the universe, right? With your eyes, can you see the universe? Whatever you are able to see with your eyes, I'm asking the question. Whether it is available or not, I'm not asking. Just I'm asking with your naked eye, can you see that one? Miss, answer is no, we can't see. None of them we can see, right? Now, here we can create with n dimensions. We can create with n dimensions. So 1 dimensional, 2 dimensional, 3 dimensional, 4 dimensions. Sir, if more than 4 dimensions are there, you told that it is not possible to see now. For example, we are having 4 columns are there. This is first column name, some column name, second column, third column, like this. Now using 3 columns, we are going to represent some plot like this. Using first column and second column, this is the plot. Using second and third column, this is the plot. Using third and first column, this is the plot. Now using the fourth column, one more column is there, fourth column is there. At a time you can't see, but after rotating this one, if you rotate that one, instead of this one, if you rotate, now instead of 3, if you get the 4 means at a time you can see only 3. But fourth one also available, third one also available. Multiple dimensions will be available, but you can see at a time only 3 dimensions. The fourth dimension you can see by rotating. After rotating, you can see only at 3-dimensional objects, right? Now here, if you go with the first 0 dimensions. 0 dimensions means np.array of a single number. Just you are giving a single number like this. This is an array. Inside that array is there. So if you check this one, what is the data type? If you ask type of ARR, and it is going to show as numpy array. It is not a int. Don't say it is as int. The output, though it looks like as an int output, but it is an array, right? Now, similarly, it is a 1-dimensional array. This is called as 1-dimensional array, where you are having only one list is called as a 1-dimensional array. And how you can see what is the dimensions means by using a.ndim is the attribute available. Ndim gives you the number of dimensions. If you ask like this, it is going to say it is a 1 dimension. If you ask shape gives you 4 comma. The syntax was written in terms of 4 comma like this. 4 means number of elements and it is a 1-dimensional. 4 number of elements are there, and since only 1 number is there, it is a 1-dimensional. So 4 comma 1, if you write the second one number means it is a 2-dimensional array. For 2-dimensional array, for 3rd-dimensional array, 4, 1, 3, something, you are going to get next number. How many elements are there in that dimension? Elements in each dimension you will get here. But total number of dimensions you are going to get by using the shape. 4 comma is the syntax, how it is getting represented, the 1-dimensional. 1-dimensional, it is going to be represented like this. 2-dimensional will be represented like this. 3-dimensional will be represented like this. 4 dimensions will be represented like this. Don't focus on the number. The way of representation only. Numbers are instead of 0 or 10, whatever it is. Now, what are the number of elements are there? Yes. Yes. It is going to be read as a list and it is getting appended and it is going to be stored as an array. The object will be created with respect to by using the single item within that. Right? Now, let us get into the 2-dimensional. What is meant by 2-dimensional means nothing but nested list. So where this is the first dimension and this is the second dimension. 2 dimensions. A 2-dimensional array will be represented by this, like this. Okay, where the first dimension and this is the second dimension. If you ask n dimensions, it is going to shape 2. And what is the shape means? 2 comma 3. 2 comma 3 means with respect to 2 rows and 3 columns are there. 2 comma 3 indicates that 2 rows and 3 columns. Right? Now, if you want to represent any matrix like this, Matrix also 3 by 3. 3 by 3 is the shape, but it is a two-dimensional only. So number of rows and number of columns. Just if you take like this, see, this is the first dimension, second one, third one. So here we are having with respect number of rows is equal to one row, second row, third row, 3 columns and 3 rows. What is the shape, miss? 3, 3. You are going to get the output as 3, 3. Right? Now, so these are with respect to arrays. Now, how we can create the arrays by using the functions within the Numpy? Means in that first one is called as np.arrange, not range, arrange. Arrange means array. A stands for array. Range of 10, 100, 10. What is the meaning of this? Starting point, ending point, and increment. Increment with 10. Where the ending point should not be included. Now, normal range, whatever the normal range is there, the same concept will be applicable. But with respect to, it is going to give the output as an array. It is not with a list. It is an array. The output we are going to get as an array. That is 10, 20, 30, 40, 50, 60, 70, 80, 90. Now tell me, what is the dimensions of this? It is a one-dimensional array. Exactly. Then how the shape will be represented for this one? If you ask a dot shape, what it is going to give? 9, comma. So it is going to show that 9 elements are there, 9, comma. And what is the end dim is? It is a one-dimensional array. A dot end dim is one-dimensional. Right? When you are representing the two-dimensional, you are going to take like this. This is the two-dimensional. So you have to fill the values like this and you have to conclude. This is called as two-dimensional. Now, if you want to third dimension, three-dimensional, generally, of course, now we have not discussed here with respect to called as three-dimensional, but immediately student will ask, sir, if I want to create three-dimension. Okay. Because they are not interested whatever we have completed. Nah? Whatever is there, which is not important, that is more important. Right? So generally the student will ask with respect to 3 dimension. Now what we are going to say is multiple 2 dimensions is called as 3 dimension. For example, Rubik's cube is there. Rubik's cube in front, whatever you are going to see, the 9 like this. Nah? This is a 2 dimensional. Left side, one more 2 dimension. Top, one more 2 dimension. Bottom, one more 2 dimension. Right side, one more 2 dimension. Like this we are having with multiple 2 dimensions into one. And this 3 dimension we are going to discuss in the future when we are discussing the 3-dimensional arrays by using the images. When we have to work on the images means obviously we have to go with the 3D only. Any image is a 3-dimensional only. 3D images are again different. Of course, this Numpy 3D again we are going to discuss in detail there. Now, as of now in today's class or in the further classes till we enter into the unstructured data, till the images, we are going to work only on the 1-dimensional data or 2-dimensional data. 1-dimensional data means one list will be there. 2-dimensional data means rows and columns will be there. Rows and columns are there means it is a 2-dimensional data. Only one list is there means it is 1-dimensional data. Okay. Now, second option of line space. Second option is called as line space by using the line space. So here line space of 0, 10. 0, 10 means I want between 0 to 10 4 data points I want, including the 0 and 10 also should be included. Along with this 4 points I want, which are equally distributed. Okay, for example, if I take with respect to 3, if I write 3 means this one is going to be 5. So you are going to get equal distance by using the 5. From here to here, whatever the distance is there, from here to here also equal distance. Line means this is one line. Space means equal space. How many number of data points you want means 3. From where to where? 0 to 10. Both of them are inclusive. Both of them are inclusive. So you will get as 0, 5, 10. Sir, I want 4 data points. Now between 0 and 10, I require 4 data points which are equally distributed means 3.33, 6.66 and 10. Don't ask 9.99. Around 3.33, 6.6667. Okay. Right? You are going to get like this. Total number of data points are going to be 4. Number of samples are going to be 4. This is one of the second one. If you want 5, so it is going to take from 0 to 5 data points. Total 5 data points should be there, but everything should be equally distributed. That is 0, 2.5, 5, 7.5 and 10. So where we are going to use this one is in order to make some kind of graph sheet. For example, I want to make with respect to graph sheet on x-axis from 0 to 100 with an equal distance of 111. Now what I'm going to do, 0 to 100 I will take with the 100 samples. Automatically equal distance is going to be 0, 1, 1 like this one, right? I want including of last one also miss 101 I have to consider. Then only it will going to, if I consider only 100 miss, then 1.01 something is going to have like this, because total number of samples should be 100, right? So total number of, because here the last number also included, first number, last number included. If last number is not included miss, 0 will be included. Okay. Now 101 miss, then equal distance of like this. Total 101 data points are there, including 0. Excluding 0, 100 data points, including 0, 101 point. So when you are making some kind of graph sheets, means in the future classes, we are going to use Matplotlib and Seaborn data visualization. At that time, it is going to be useful, right? Now here, if you want with respect to 10 data points, means it is going to give 10 data points. If you ask 11 data points, means it is going to give 11 data points. The syntax is nothing but the line space is going to return the equal space numbers over the given interval. Whatever the interval is there, it is going to return the over the equal interval within the interval and within the number of samples, starting data point and ending data point along with the number of samples, right? If you open this shift tab, that is help file of this, here you can clearly read starting, stopping, and if you see here, returns equally spaced numbers over the interval time, where the returns the calculated over the interval, whatever the interval you have given, and it is going to start the sequence and end point also included. And the number of samples should be int only. Don't write 1.4 samples I want. It is going to throw an error. Number of samples can be int only. It can't be neither non-negative. It should be non-negative. It can't be negative also. I want -5 samples, -4 samples, 1.4 sample, 1.5 sample. It is not going to give anything like this. If you don't write anything, if you don't write anything if you don't write like this, by default, it is going to take 50. If you observe this one, inside this function, there is a with respect to here default value, whatever the number of samples is equal to, default is 50. By default, it is going to give the 50. So if you want only 10 miss, you write with respect to 10, or 11 miss 11, whatever the number of samples we require. Next one is called as np.zeros. It is going to generate the zeros, complete list array of zeros only. Every value will be filled with 0. So just you have to write the shape. The input should be given as the shape. For this function, for every function, one functions are there. For example, certain function is there. Let us take like this. Def, okay, def srk1, okay, and a. And I'm creating with respect to called as a plus hello. Now, if you give the int value, it is going to work. It is going to throw an error. Return a plus hello is the function. If you give float value, it will work. If you work with respect to list, means it will work. No, it is going to work only with the string only. String only will be concatenated, because in the output of this variable is string a plus hello. This function was created in such a way by giving a as the string. Sir, how I can know a is a string or a is a int? How I can know is that we have to see in the help file. For any function, new function, when you are applying a new function, what is the input parameters it is going to take and what is the output it is going to give? Everything you are going to see in the help file. You should know how to read the help file of any function. Help file is nothing but, for example, this one. Let us take np.zeros. Okay, this is the function. First, you have to write the function like this. After that, inside this function, you have to use the shift tab. Then it is going to work. Now, if you open like this, it is going to show shape. Input argument is shape. Data type is equal to float. This is the default arguments. Already I have told you, right? A function is having is equal to miss, it is called as default parameters. These are the default arguments or default parameters. Which is compulsory parameter is only this one. So it is going to return a new array of a given shape and type. Whatever the type you have given or whatever the shape you have given, based on that, it is going to return. For example, here, if you give with respect to shape as 3 comma means 1 dimensional. Means it is going to give 1 dimensional array of 3 elements of 3 zeros. 1 dimensional 3 zeros. Why 0.0.0 is there? Because data type by default is equal to float is there. If you want to change this one to int means you have to write d type is equal to int. Then automatically you will get the int. Right? If you don't write data type is equal to int means by default it is float. In the help function you have read, right? You have read now that with this nothing but shape. Based on the shape, it is going to generate the array. A new array will be generated. Whatever the shape you have given, it is going to fill the values with zeros. The array will be filled with zeros. If it is one dimension means 1, two dimension means 2. For example, two dimension array of 3 by 3. Okay, 3 rows, 3 columns. I want to be filled with entirely 0. So it is going to give me like this. When you are going to use this one, when you are working on the null matrix, in the matrices, we are going to work on the null matrix. Nah? At the time, it is going to be useful. For example, you want to add the multiple matrices, matrix 1, matrix 2, matrix 3. That is nothing but 2-dimensional. Multiple 2 dimensions you want to add, assume. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15, 13, 14, 15, 16, 17, 18. Something you are having like this. And you want to add. Now, if you remember, in the list, if you want to add in the sequential order, first we have to initialization with what we have to do initialization? 0. Do you remember? When you want to add the list of elements, what are the list of elements we want to add? First, we have to create the initialization with 0. Then only we can add the every element in the list. Similarly, for the 2-dimensional arrays also, you want to add everything means you have to initialize with some value 0. For that 0 array also is required, right? How the 0 value was created earlier, here also 0 array has to be required. So that is the reason we are creating the 0, right? Next, random.randint. In the SLS class only we have completed this random module. Similarly, np.rand.randint 1, 45, 5 means it is going to generate 5 values randomly, integers. Sir, how 5, sir? Yesterday we have discussed only this one time only. Na? So it is going to take 1 time only. By default, 1 time. If you want 5 times means what we have to write? In the SLS class, what we have to write? For loop. For I in range of 5, random.randint, you have to execute the same program for 5 times. But here, no need of writing the for loop because array is included the for loop. List plus for loop is called as Numpy array. List plus for loop. So just we have to write 5. Now assume that this code is not there. Numpy is not there. Or Numpy is there, and what is the backend code of this one? Can anyone tell me? What is the backend code of this numpy.random. Inside the Numpy module, there is this function. What is the backend code of this one? Nothing but for I in range of whatever the number here they are giving, this number. This number is they are going to create while definition, function definition, randint function. The start, step, start, end, and number of samples. Number is equal to, if you don't write anything by default, 1. They have given that number. While creating the function, you can create like this. Na? So they have taken for I in range of whatever the values start, end, and whatever the number of samples n is there. For this, it is going to apply print. Instead of print, what it is going to do is L is equal to empty list. For this L, it is going to apply the L.append of random.randint. Just it is applying this one. So let me write clearly once again the program. Def what are the randint start end n is equal to 1. They have created the function like this within the Numpy module. Within the Numpy module, the function was created like this, where it is having L is equal to empty list for I in whatever the given with respect to randint. Okay, for I in next nothing but range of n, L dot append, or for example, you store a is equal to random dot rand int of start comma end, and you are going to append L dot append of a. Whatever this value is there, you are appending, and finally you are returning the L. This is the backend. Instead of writing these many 5 lines of code, simply I have written only 1 line by selecting the number of samples. Got the point? So now you can understand in the functions, sorry, in the NumPy, we are having different types of functions are there. And what is the use of each function we are understanding one by one. Right? So here, just if you see here, the number of values I'm selecting randomly 5. Now here also we are having the same kind of indexing. If you go with the indexing, so here we are having the number of elements like this. np.arrange of 0 to 31 with the increment of 3 means 0, 3, 6, 9, 12, 15, 12. Like this we are having up to 30. And if you ask with respect to print here means it is going to print up to 30 with an increment of 3. Now if you go with a of 5 means this is 0, 1, 2, 3, 4, 5. Index 5 is nothing but 15. Just it is applying the same kind of indexing whatever you have done in the list. There is no difference. Now, if you go with the slicing, once again the same concept. In the list, whatever we have done, the same thing. Once again, it is the same. Same 1 to 8. So 1 plus 2, you have to do 1, 1, 3, 5, 7. These are the 4 elements you have to select. In the 1 position, 3 is there. And in the 3rd position, 9 is there. In the 5th position, 15 is there. In the 7th position, 21 is there. So 3, 9, 15 and 21 is the output. Right? The same kind of slicing operation, whatever we have done in the list, no difference. Indexing is no difference. Slicing is no difference. Now, sir, you are going somewhat fast. Who is going to say this dialogue is? Who has missed the previous classes or who has not revised? Who are on the track, who are listening every day or who are practicing every day functions concept or for loops concepts or this one? Just today's class for them, it is going to be revision only. Sir, it is simply whatever we have till now, whatever we have done, that same thing only you are explaining now. Did I add any new word like other than for loop or other than a function, how to create the function or arguments, default argument and input argument, what type of argument you have to give? Did I add any new concept here? Now, if you are feeling something fast miss, surely it is equal to that you are not practicing. If someone says that, sir, you are a bit fast, immediately I will understand that one. Of course, I am going to go slow only. After that feedback, I will go slow. But I will understand this particular person. For example, in this class, one of the student has missed the for loop. Assume he has missed that concept of for loop. Now, for today, for him, what is the class? No, he will not even understand the first line of code also. That is array. What is array and how the list is converted to an array also, he will not understand. Assume the person has missed the list. He will not understand what is meant by append. Assume the function, he has missed the concept of function. One of the student has missed the functions. He don't know what is meant by function and what is meant by def I am writing. And what is meant by return also, he will not understand. Assume one of the student has missed STS class module. He don't know what is meant by this np.np. Now, whoever has attended list and for loop and the functions class with along the modules, for them today's class is simple. Same dialog, copy paste, dead easy. Right? So if you come in a sequential order, automatically everything is going to be easy. If you miss one of the class, and if you have not taken the notes from your friends, or if you have not practiced anything, and you have sitting in the next class miss, data science is going to be the difficult subject. I told you at the starting in the demo session also, and now also, data science is an interlinked subject. When the data science is an interlinked subject means we have to follow in the sequential order. If you miss the sequence means everything will be collapsed. Right? In this class, I can see some of the students who has missed the last class and the previous classes. I can see their faces. Okay, every day I'm seeing you now. You are also seeing me. Common. So obviously, I can also remember some student faces, right? Who has missed STS class and day before class. For them, today their expression will be different. They will see like this only. No expression in their face. Whoever are understanding, they'll shake their head like this. Something they are understanding. Based on their face, we can understand they are understanding or not. Right? That is very easy. Now, who has practiced and who has not practiced also we can understand easily. Based on your silly questions, some students are asked with respect to, sir, what is this index of 5? Can you explain once again, miss? Oh, what is that level? We can understand. This same question has to be asked in the list. There it is clear. Now it is doubt, miss. What type of person he is? In the list it is clear. Indexing in the list it is clear, it seems. But in the NumPy, the indexing is not clear, it seems. Now what you will understand from that student? What your mind will say for you? If the student comes to you and if they ask this question, what your mind say? The same thing for me also, na? Obviously. Right? So that is the reason. Please practice every day. If you want time, tomorrow Saturday, day after tomorrow Sunday, 2 days holidays are there. So, no sir, extra one more day also we want time. Ask directly. I will give the break. 1 day class also will stop. Not a problem. But without understanding the previous class, if you sit for the next class, miss, data science is going to be difficult subject in the future. Right? Multiple times I am saying, because this is the live example. Because in today's class, list is important, for loop is important, function is important, module is important. Without all these 4, if one of them is missed also, today's class will be some kind of Kannada movie for you. Okay. In future, it is going to be as a Korean movie. Okay. If you don't practice every day. For example, let us understand today NumPy was discussed. We are discussing NumPy now. Next class pandas, in the next class furtherly. For next 10 days, don't open your book. Just give a try. If you are interested. 10 days, don't open the book. On 11th day, come to the class. It is going to be Korea movie for you. If you want, you can write. By default, it is installed. By default. In the Jupyter notebook or in the Anaconda completely, who are using Anaconda, by default, that particular library will be installed. Yes, like there we have to install separately. Who are using separately Python, using the Python they are doing now, they have to do. Anaconda, they have installed, miss, by default, all these libraries will be installed. Whichever the library you have to install separately, that I'll explain. In meanwhile, if you want, miss, you can use pip install NumPy. That's it. Installing a library in Python is this one. Pip install NumPy. Okay. Pip install NumPy. No need to install. None of them no need to install. Okay. Is that clear, guys? Now, next one. So here we have seen with respect to the indexing. Now tell me, guys, assume this is a list only. Using the list slicing operation I have done. And I have got this one. Assume this is a list only. Don't think it is an array. Normal list only. 0, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Assume this is a list only. It is a list only. And A of 1 colon 8 colon 2. I have got the output as 3, 9, 15 and 21. This is also a normal list. Output also you are going to get as a list only. Since it is a list writing means automatically output also list only. This is common. Okay. Now what I want is, instead of 0, 3, 6 like this, there is no pattern is there. First I want this one. Second I want this one. Third I want this one. Next I want this one. Now how to select in the list? Whichever the index numbers you want, that one you have to print. In the list, what we have to do? Separately, we have to write what are the index numbers you are choosing, and every time we have to append, right? For in, what are the numbers? What are the index numbers you want? That index numbers. That is nothing but for in the given list of index numbers. What is the index number of this one? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So for in index numbers of 0, 4, 5, 7, using this, you want to take with respect to values of L of 0, A of 0, and this has to be appended in the empty list. You have to take an empty list, and this empty list has to be appended. That is L dot append of A of I. Whatever I value is there, A of 0, first it is going to take A of 0, and A of 0 will be appended in the L. Next, A of 4 will be taken, and it is going to have appended. A of 5 will be taken and appended. A of 7 will be taken and appended. Empty list, for loop, and append. This everything in shortcut we are going to get here. If it is a array, if it is an array, now how to get the same thing, you know? Just you have to write, instead of one index number, for one index number you have to take with respect to single brackets list of index numbers na, one more list. What are the list of numbers you want? 0, 4, 5 and 7. So you have to write like this and you will get the output directly. So A of with respect to list of index numbers you have to write. This main first bracket indicates with respect to index numbers. This indicates index numbers. Within that, list of index numbers you are writing. List of index numbers of 0, 4, 5, 7. Whatever you have written earlier, the code, if by using the for loop and the same thing, the same answer you are going to get this one. This is the normal code. This is in the Numpy. So this same list, whatever you have written here, the same list you have to bring inside this. So in the Numpy, we can do the same thing very easily. Right? So here, one of the student is asking to repeat once again. So just values are not same. Let us take one example. Let us write a normal list on I am writing 0, 3, 4, 3, 6, 9, 12, 15, 21, 18, 21, 24, 27, 30. Okay. Now, you want with respect to index numbers of 0, 1, 2, 3, 4, fourth index number, 0 index number, and fifth index number, and seventh index number, right? So what I'm going to do is for I in the list of index numbers are 0, 4, 5, 7. For I using this one, I am asking whatever the A of I is there, that I am selecting. Now print A of I. If I ask print of A of I, let us see first print. If print is working, means append only now we have to do. Print is working. Same values I'm getting. So since print is working, automatically simple, you have to do list.append. List.append of this one. Whatever the output is there, every time you have to append. For that, we have to create an empty list. L is equal to empty list. And we are using the finally the print of L. Okay. Now if you check the values, see the same thing now. This is with respect to core Python code. This is with respect to array. Now if A is array means simply you have to write like this. If the A is list means you have to write this code. Okay. Now that is the advantage of an array. Every time writing for loop, instead of writing like that, convert the list into directly array. Automatically it's for loop only. By default, for loop is applied for the array. Okay. Is that clear? Next. Now, let us come one by one. One by one we'll come. First, this example is clear, miss. We'll see one more example. Okay. Now, in this way, we can access the multiple index values. The multiple index we can calculate by using the syntax. For indexing multiple values in syntax is nothing but if you are having a regular pattern, means go with the slicing. Slicing will be helpful if you are having a regular pattern. Like with respect to step of 2, every time the equal pattern is there, means slicing is best. If you are not having a proper pattern is not available, means in that case, the syntax is array. Whatever the array is there, within the array, you have to take the list of index values. Within this list of index values. Okay. This array you have to take with respect to the list of index values, where I'm going to take this one. Okay. Array of list of index values. This is the syntax in order to access the multiple values. Array in the bracket, you have to take the list of index numbers. Index numbers. What are the index numbers? Not values, numbers. Right? Index numbers. So in this way, you can access the list of index numbers, whatever the index numbers. If you want to repeat, also repeat. You want to repeat for 2 times, repeat. 10 times, repeat. Whatever you want, you can do. And you are going to have the same thing. So here, list indexing must be integers, not slicing. Integers. Just a minute. Oh, already A was converted with respect to, see, why it is showing like this? Can anyone tell me? Already A, what is the A? What is the A? It is not the list of, it is not the array of values. It is a list of values. Before that, I have shown you one example and I have deleted now. A is that one. So if I ask A means it is a list of values. It is not the array of values. If you ask what is the type of A, it is showing as a this one, list. This is applicable only for array, not for the list. This concept is applicable for array. So first, that if you delete this one, how I can know that you have created that in between you have written a program with A like that? How I can know? So if you see this one in the order, 37, 38, after that 44 is there. In between something you have executed and something you have deleted also. So when you are doing the proper order, everything will be correct. Now if A is nothing but this array. Now if you apply this one, it is going to repeat. It will work. Right? It is going to, this kind of syntax is applicable for A is array. If A is list means it is not going to be applicable. Next, we are having next type of indexing called as mask indexing or fancy indexing. Just you can write a condition and the values which are satisfying the condition will be printed. Inside that, till now we have written the index numbers. We can write even the condition also directly. Wherever the output is true, that output only will be written. If it is false means that it is not going to return. They have written the program in such a way in the backend. If the output is equal to true, append that values. If the output is equal to false, don't append that one. Right? So just see here. If I write like this, true, the first element, whatever the first element is there, this is true. This is divisible by 0. Yes. Divisible by 2. No. 6. Yes. No. Yes. No. Yes. Like this we are having, right? The same thing. True, false, true, false, true, false. Now I want not true, false. I don't want the output as true, false. I want the values. Values means A of. A of means you are going to get within the A, whichever the values are satisfying the condition. Within the A, whichever is satisfying the condition, it is printing the values. This is called as mask indexing or fancy indexing, and which we are going to use in the real life. One of the most important one. So what is the backend code of this is nothing but def. Whatever the array they have given, okay, that is nothing but array. Some array will be there, right? Whatever the array they have given, for that array, check whether if the given number, whatever the number is there, that number is divisible by 2 or not. Just check this one. If it is divisible by 2, append to the empty list. For loop only, in between for loop will be there. For given values, for I in the given values, for I in array, whatever the array is there, for I in array, for each of them, for I value, you check with respect to whether it is divisible by 2 or not. If it is divisible means, then append. If it is not divisible, else. No need to write even else also. No need to write else also. If it is divisible by 2, append. Not miss, no need to do anything. Leave it. So which are getting appended, only we are printing the L. L miss, which is nothing but that list in the back end. This is output as array. Array just satisfying the condition. Once again, in the what is the code? For loop. Within the for loop, if and else is there, append is there. For loop plus list plus append is called as an array. Now it is getting clear with multiple examples like this. Every array is a combination of list plus for loop. Everything, each and everything is a combination of list plus for loop. Right? Numpy is a mutable object. Numpy is a mutable object where we can replace, because in the list, whatever we can do, because this was created based on list means obviously whatever we can do in the list, the same thing we can do here. In the list, we can replace the value. We can add the value by append. We can remove the values. The same thing we are doing here. First one, replacing. How to replace? A of 5 is equal to 50. Means this 50 will be sit in the position of 5th position. It is going to replace that one. This position will be replaced. How we have done that same type of replacement in the list? The same way as it is. If you want to do multiple values, has to be replaced with 40. Take the multiple values. Instead of writing for loop, if you're not having this one, for example, I want to replace this value along with this value. Two values I want to replace with 50. Okay. So instead of 50, I want to replace with 80. Assume that this is a list, again list. Assume this is a list. Now for list, within that, I want to replace this one and this one. These both of them I want to replace with 80. What is the code I have to write? What is the code I have to write? For I in whatever the index numbers are there, 0, 1, 2, 3, 4, 5, list of index of fifth one, 6, 7, 8, 9, 10, 10th one. These both index numbers, just you have to replace with respect to this one. So the L of I should be replaced with 80 and print the L. Print L is the code. Only this first I will be taken as 5. L of 5 will be equal to 80. Next I is equal to 10. L of 10 is equal to 80. Automatically print L means that two positions will be changed. So what are the two positions? 5 and first one, fifth position, and what is the second position? 10th position. These two positions you want to replace with 80. Two positions are replaced with 80. This one, whatever you are writing in here the index. Same as whatever I have told you earlier, this one. How you are accessing a single multiple access? The same thing. List of values, list of index numbers. A of bracket, within that list of index numbers. And equal to whatever the number you want to replace. It is just replacing that value. Is that clear? Now, sir, whether array has this function or not. If you want to ask a question, sir, whether array can do this one or not, means first you tell me with list we can do or not. With the list plus for loop we can do, means with array we can do. Simple. With this it is not possible, means with array also it is not possible. Before asking a question, sir, we are using array, how we have to do, means first tell me using the list and for loop how we have to do. Because every numpy function was created using those two only, na? Is that clear? Now, how to add? I have shown you how to replace a single value and how to replace a multiple values. Similarly, how to replace with respect to, how to add the value. Add the value is nothing but append. You are going to append. It is going to append as a single element. It is going to add as a single element. It is not going to take as a complete list. It cannot be appended. Because though the entire list is appended also, you can't show one more bracket like this now inside. Every value is a unique value only. Right? Now how to delete? How to delete means in the array, for example, this is A. Now your A is this one. Within that, you want to remove the index number 2. What is in the index number 2? 0, 1, 2, 8. 8 has to be deleted. It is going to delete the 8. You have to write the array and what is the index number you have to delete. This function was created by considering two inputs. One of the input is, sir, I want to have 8 numbers, sir. Means whichever the value I want to delete, that value I am going to give, sir. This function was not created like that. This function was created by taking the array and by taking the index value, not the original value. How the function was created, according to that we have to use. We are not creating the functions, we are learning the functions. Already these are created. These are already created, just we are learning. So A and D is called as end. In English language, A and D is called as end. Why it is called as end only? We are not questioning, we are learning. Okay, and it is called as A and D. And where we have to learn, where we have to apply, that we are applying. We are not questioning why it is called as A and D only. Why it is called as A and D only? Why you can't call as Unda? Something like this. Something. Why you can't call that one? If I ask the question like this, what is the answer from you? Multiple elements. If you are deleting a single element, means single value you are writing as the index number. If you want to delete the multiple, means list of index numbers. The only difference is list of index numbers, right? So you can go with the list of index numbers and it is going to delete in this the list of index numbers like 0, 1, 2, 3, 4. So it is going to delete the index number of 2 and 7. These values, that is index number of 1 and 2, that these two values will be deleted. After deleting these two values, now balance is 4, 4, 5. You are going to get 4, 4, 5, right? Next one is np.sort. Sort means it is going to sort in the sequential order. By default, it is going to take in the ascending order. In the list.sort, how we are having the same way, np.sort. Next, in the list dot, we are having copy. shallow copy, deep copy. Similar way here also we are having the same thing. Once you create a dot copy, it is going to create a new object. And in that new object, in that first position value will be replaced with 100. So what it is going to do? In the backend, A is equal to 1, 2, 3. And B is equal to A dot copy means it is going to create one more like the same 1, 2, 3. And B dot 0 of 100 means in the B, the first position will be replaced with 100 and A will be as is. Now print A means 1, 2, 3, print B means 100, 2, 3. You are going to get like this. Right? The same way, whatever we have done in the list, the same thing. We can add, we can replace, we can remove, and we can copy the elements. Right? And in the Numpy, we are having the operations. Multiple operations are there, out of which the first operation is called as flattening. Flattening means converting n-dimensional array to a one-dimensional. So for example, you are having this one, a two-dimensional array of like this. 1, 2, 3, 4, 5, 6. This is a two-dimensional array. Now this entire two-dimensional array will be converted to one-dimensional. First row, 1, 2, 3, second row, 4, 5, 6. Like this it is going to take and it is going to convert to one-dimensional. For example, you are having like this. Assume 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 by 3. 3 rows and 3 columns you are having like this. First row, row wise, it is going to make with respect to row wise. It is going to flatten by row wise. First row, followed by second row, followed by third row. Row wise it is going to do. The function name is called as ravel. A dot ravel. And you are going to get like this. It is going to convert the two-dimensional array to one-dimensional array. Right? Next one is called as reshape. Reshape means anything you can convert the shape. Any shape can be converted. For example, here if you take np.arrange of 20, what is the meaning of np.arrange of 20? Range of 20, what is the meaning of range of 20? 0 to 19. Arrange means nothing but array. Same array you are going to get as a array. The same values you are going to get as an array, that is 0 to 19. What is the shape? How many values will be there? 20 values. What is the dimension? One dimension. So 20 comma. It is going to represent 20 gamma. So 0 to 19 you are going to get as an array. Now in this you want to reshape because 20 values are there. Na? You want to reshape into new one like 2 comma 10 means 2 rows with 10 columns. So you want like this 2 rows with 10 columns. You can create a two-dimensional array in this way. Sir, for example, if I am asking 2 rows, 11 columns, assume how you can convert, it is going to throw an error because total number of values are there. How many? 20 values. Now here, how many positions will be there? 2 into 11 means 22 positions will be there. Means one more column, one more position, 22 values will be empty. In 22 positions, how 20 values will be fixed? So it is going to throw an error here in this case, value error. 20 values cannot be kept in 20 comma 11. 20 values can be kept either in 20 comma 10 or if you're not interested 20 comma 10 means 4 comma 5. This is also possible. 4 into 5 29. So 4 into 5 also possible. 4 rows and 5 columns or 5 comma 4. This is also possible. And if you want with respect to 20 comma 1 also possible. 20 rows with 1 column like this. 20 rows you are going to get a two-dimensional array of 20 comma 1. No sir, I want with respect to 20 as one with respect to one dimensional. If you want one dimensional, it is going to take in one dimensional. Two dimensional means with respect to both the values, if you multiply means total should be 20. In 30 positions, you can't keep the 20 values. Right? If the positions are more also you can't keep, or if the less positions are there also you can't keep. For example, you are asking within this 4 comma 4. 4 comma 4 means how many positions will be the total? 16 positions will be there. 4 rows and 4 columns means 16 positions. In 16 positions, 20 values, how you are going to fit? It is going to throw an error that I can't fit 20 in the 4 comma 4. Right? Just next one is A is equal to np dot array of a two-dimensional. Once again, you are having a two-dimensional, and this two-dimensional, since here, what is the array you are having? Like this. Now I have shown you how to convert a one-dimensional to a two-dimensional. That is fine. And I have shown you how to convert a two-dimensional to one-dimensional. This is also fine. That is ravel. Now how to convert within the shape? Now here I am having 2 rows and 3 columns, but this has to be converted into 3 rows and 2 columns. Now I want 3 rows. So how it is going to do is 1, 2, 3, 4, 5, 6 will be converted as 1, 2, 3, 4, 5, 6. Sir, why it is not taking like this, sir? 1, 2, 3, and 4, 5, 6. It can take like this now. This is called as transpose. Rows are converted to columns. Columns are rows means transpose. This is called as transpose. Whereas when you are using the reshape, what happens in the back end, 1, 2, 3, 4, 5, 6, we are considering like this now. Automatically in the back end, first it is going to apply the ravel. First it will convert to ravel. That is one dimensional. That is 1, 2, 3, 4, 5, 6. Now it will apply the new shape. Whatever the 3, 2 is there. 3 rows. So 3 rows, 2 columns like this. First the positions will be made. In that each value will be substituted like this. It is going to work in this way. So you are going to get the output like this 1, 2, 3, 4, 5, 6. Now whenever you are applying the transpose, the columns will be converted as rows and rows will be converted as columns. That is, this entire thing will be converted as column. And this one will be taken as second column. Second row as second column, first row as first column. Right? That is called as transpose. Right? Next one. Sir, you have applied the np.sort on one dimensional. Okay. For two dimensional, how we are going to apply the sort? For example, I am having a two dimensional like this. 1, 2, 3, 8, 9, 10, 14, 15, 14, 2, 4. Something I am having like this. Okay. Now, if you want to sort row wise sorting or column wise sorting, row wise sorting means you have to take axis is equal to 0. Is called as column sorting. Axis is equal to 1 is called as row sorting. Okay. So here if you observe this one, 5, 4, 6, 2, 8, 2. This is a two-dimensional array. Now if I want to sort, if it is a one-dimensional array means it is very clear. You can sort in the ascending order or descending order. It is very clear. But if you are having a two-dimensional array and if you want to sort that one in the ascending order, by default ascending order, if you want in the descending order means reverse is equal to true. You have to write. Now you want to do the sorting. You are having two options. Option number 1 is called as 2, 5, 4, 8, 2, 6. What is this is called as column wise sorting. I have checked in this column which is the least one. First I have placed that one, second one. This is called as column sorting. Second one is row sorting. That is 4, 5, 6, 2, 2, 8. This is called as row sorting. This is called as column sorting. So row sorting you can do by applying axis is equal to 1. Axis is equal to 1 means you are going to get row wise. First row only it will collect and it will apply the sorting only on the first row. It will not even check in the second row what is there. In the first row 4, 5, 6 it is going to do the sorting 4, 5, 6. In the second row 2, 2, 8. You are going to get like this. If you apply the axis is equal to 0 column wise, each column it will take and within that it is going to apply 2, 5, 4, 8, 2, 6. You are going to get like this. This is the output. Is that clear? So one is called as row wise sorting and one is called as column wise sorting. And when you are having a two-dimensional array, then at the time you have to use the axis word. When there is a two-dimensional, you have to use the word called as axis. If you want to work on anything. Yes. Reverse is equal to true. In the list how we are going to get same way, same thing. Descending order means reverse is equal to true. Just you have to write reverse is equal to true. In this we are having the order. See here, A is equal to array, axis, kind, and order. Which order you want, ascending order or descending order. And according to that, it is going to give whatever the order you have to specify. Right? Next, A is equal to np.dag of 1, 2, 3. Dag means it is going to take the diagonal elements. Diagonal elements of 1, 2, 3 like this. Okay, these elements will be taken as the diagonal elements and remaining values will be created as 0. The array will be created by using these values as the diagonal elements. Okay. Now, sir, you have told the indexing, if it is a one-dimensional array, 0, 1, 2, 3, like this, if you are having something like this, and A of 0 means it is going to give 0, A of 4 means it is going to give the output as 4. Indexing is with one dimensional, it is clear, sir, because it is as similar as list. But here, in this case, indexing, how I am going to use? Do you remember in the matrices, you are having 1, 2, 3, 4, 4, 5, 6, 7, 8, 9. This every portion is given by Aij. Do you remember? Where I is row number, J is column number. Right? In the max, this is the notation. In the max, it is the notation. The syntax in the max is this one, but the syntax in the Python is within the array, you have to use comma, the first one and second one, the I and J. I is nothing but row number, J is nothing but column number, but notation is not like this. Notation is with respect to square bracket, right? Now, here, whatever the I is there, you can't use here. What is this row number miss? Here, first row, second row, third row. That is normal max. But in the Python, the index numbers you have to give. Because this brackets, whatever you are using is index numbers bracket. So automatically you have to give the row index numbers and column index numbers. Now this position is A of 0, 0. This is A of 0, 1. This is 0, 2. This is 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2. Same. So now what is, according to this one, for this matrix, what is in the index position of 1, 1? So index number of 0, 1, 1, 2, 0, 1, 2. So one portion of this one is, this is the row, one portion is this one. This is the point, which is 2. So it is going to print the 2. And this value you want to replace. This value you want to replace with 25. Just try with the replacement. Instead of selecting a single value, you are taking the index number 1, 1, that is 25. This 25 will be replaced. It is getting replaced with 25. Is that clear? Got the point? If it is a one-dimensional array, miss, you have to use A of 1. Simple A of 1. Don't use the comma. A of 1 only you are writing. Sir, multiple values if we have to replace, miss, list of values. That is different. That is again one more bracket is there. If you don't write one more bracket, miss, then it is not considered as a list of values. It is considered as an array. Two-dimensional array. It is going to be a problem. So the second, when you have written this second one, that is considered as the list of values. Right? Is that clear? The syntaxes. Next one is arithmetic operations. That is A is equal to np.array of 1, 2, 3, 4. And if you print this one, 1, 2, 3, 4. Now, if you want to add plus 1 means not with the array at the end. That is not appending. It is just adding for each and every element. For loop. It is applying for loop. For each and everything, it is adding plus 1. For every value, it is adding plus 1. Now, A power 2 means for each and every value, it is going to take 2. Power 2. That is 1 square, 2 square, 3 square, 4 square. You are going to get like this. Now, sir, A plus 1 you have done now. Now 2 square has to be done now. 1 square, why? Because I have not stored this one. I have printed only. Did I store here? Now, what is the latest A value? A value is this one only. These both are printing only. I have done printing only. Here I have printed, here I have printed. Whenever you are using the equal to symbol only, it will be assigned to the left side variable. Till that, it is not going to assign. Right? So here now I am not assigning, just I am printing only. Now here B of NP of ones. Similarly, NP of zeros, how we are having? We are having with respect to NP of ones also. NP of ones means it is going to create with 1, 1, 1, 1. Sir, NP of twos also will be there, na? No. Only NP dot zeros and NP dot ones only available. Sir, why only these two are available? Why 2 and why 3, why 4 it is not available? Because in the matrices, we are having zero matrix, which is also called as null matrix. And second one, we are having identity matrix, which is filled with 1. For these two only the upright names are there. For others, there is no names. Okay. No, sir, I want to fill the values like this. 3 by 3, everything of 2. I want like this. Now what I have to do? Just NP dot ones, sorry, NP dot zeros. Tell us NP dot zeros or ones, whatever you want. NP dot zeros, 3 by 3. 3 by 3 means automatically everything will be created as 0, 0, 0, 0, 0, 0, 0, 0. For this, add with 2. Every element will be added with 2. If you have created with ones means every element will be added with 1. So for example, I am taking with respect to a 3 by 3 matrix. See, 3 by 3. 3 by 3 means what is this? NP dot ones of 3 by 3 means by default everything are filled with 1, 1, 1, 1, 1, 1, 1, 1, 1. For this, I am adding plus 1. Means every element has to be added plus 1. That is 2, 2, 2, 2, 2. Why dot you are saying? Because float. By default, it is float. Data type is. Clear? Now, what is the A value? A is this one. And what is B value? This one. So what I am going to do is B also I am going to change like this with respect to 4 comma. Okay. Now here, what is the A values? A is one dimensional. A is equal to one dimensional of 1, 2, 3, 4 array. What is B? 2, 2, 2, 2. This is B. This is A and this is B. Now what I'm going to do is A plus B. A plus B means for each and every element it is going to add. That is 1 plus 2, 2 plus 2, 3 plus 2, 4 plus 2. For example, you have written here one more 2 also. There is one more 2 also. It is going to throw an error. If both of them are not equal, it is error. If both of them are same only, it is going to work. And now you are going to get 3, 3, 3, 3, 4, 5, 6. Because this is 2 na. So 1 plus 2, 2 plus 2, 3 plus 2, 4 plus 2. You are going to get like this. Similarly, A into B or A minus B, that is 1 minus 2, minus 1, 2 minus 2, 0, 3 minus 2, plus 1, 4 minus 2, plus 2, minus 1, 0, 1, 2. A into B, for each element it is multiplying. 2, 4, 6, 8. Element wise operation, it is just applying the for loop. In the back end, just it is applying for loop for each element. Once again, the same thing. Right? Now, here 2-dimensional array is there. So 2-dimensional array, you have shown for 1-dimensional array, okay. How to add 2-dimensional array? That is 1, 2, 3, 4, 5, 6 is there. For this, you want to add 4, 4, 4, 4, 4, 4. For this element, this will be added. For this element, this will be added. For this element, this will be added. For this element, this one. For this element, this one. For this element, this one. And you are going to get an output like this with respect to first one 5, 6, 7, 8, 9, 10. Element-wise operation. In that particular portion, in this particular array, whatever is there, in the second array, in that particular portion, whatever is there, is both will be added. Right? Now, sir, I want to do A into B. A into B means 1 into 4, 2 into 4, 3 into 4, 4 into 4, 5 into 4, 6 into 4. Each element wise. Sir, I don't want to do element wise, sir. For example, I'm having a matrix like this 1, 2, 3, 0, 1, 4, 2, 3, 5 into 1, 4, 2, 1, 4, 3, 1, 4, 4. Something I'm having like this. Right? I'm having a matrix 3 by 3 matrix. This is also a 3 by 3 matrix. Now, if you go with A into B, this is A and this is B means what is the output you are going to get? 1 into 1, 1, 2 into 4, 8, 3 into 2, 6, 0 into 1, 0, 1 into 4, 4, 4 into 3, 12, 2 into 1, 2, 3 into 4, 12, 5 into 4, 20. This is the output. If you apply directly A into B, sir, I don't want like this, sir. Matrix multiplication is not like this now. Matrix multiplication is row into this column. Again, see, this row into this column, this row into this column, like this now. That is called as matrix multiplication. This is not doing the matrix multiplication. Matrix multiplication means np.matmul is the function. When you do the matmul, then automatically it is going to apply the same concept of matrix multiplication. If you do this one A into B means by default it is going to do element wise multiplication. This is element wise multiplication. This is matrix multiplication. For matrix multiplication, you have to do matmul. Then you are going to get the output like that. For example, you have taken here 1, 2, 5, 6. Sorry, 1, 2, 3, 4. 3, 4, 5, 6, 7, 8. These two of them you want to apply as a matrix multiplication. That is this one into this one. That is 1 into 5 plus 2 into 7, which is nothing but 19. Similarly, 1 into 6 plus 2 into 8. That is 6 plus 16, which is 22. Next, this column. 3 into 5 plus 4 into 7. 28 plus 15, 43. Next, 3 into 6 plus 4 into 8, which is nothing but 50. 18 plus 32, 50. Now you are going to get output like this. Now the same thing, instead of the same matrix, if you take without matrix mul, if you do the same for the same example with A into B. If you go with A into B, 1 into 5, 5, 6 into 2, 12, 3 into 4, 21, 4 into 8, 32. You are going to get like that answers, 5, 12, 21, 32. Element wise multiplication and matrix wise multiplication. That is the difference between these two. Is that clear? Clear, guys? Next one is comparison operators. Now you want to check whether each element is same or not. That is first array. I am going to take A is equal to np dot array of 1, 2, 3, 4, np dot array of 5, 2, 2, 4. Now I want to check whether both of them are same or not. Each element wise it is going to check. 1 is equal to 5, false. 2 is equal to 2, true. 3 is equal to 2, false. 4 is equal to 4, true. So it is going to give like this. No, sir, I don't want like that with respect to like, for example, second one, A is greater than B. Okay, now A is greater than B, element wise again you are going to check. Now my requirement is not that one. My requirement is entire array is same or not. Entire array, not with element wise. Entire array is same or not means you have to use array underscore equal. Then it is going to check complete array wise, not with element wise. Overall complete array. Now tell me A and B both are equal or not? No. Array of A and B is equal or not means answer is false. A and C, everything, every element is same, right? As it is, both are same, na? Then it is going to give true. If every element is same means total it is going to give. So first you have to execute this code. Now it will work. This cell was not executed earlier, right? Now A is equal to C means it is working. True. The output is true because all the elements are satisfying the condition. The entire array is satisfied or not. Complete array. If you don't write like this, if you write like this means element wise. This is element wise. This is complete array wise. That is the difference, right? And last, final, mathematical operations. Like you can apply the sign, np.sign, np.log, np.exponent. For each and every value, it is going to apply this one. First, you have got array of 0, 1, 2, 3, 4, 5. np.exponent of m is e to the power of 1, e to the power of 2, e to the power of 3, e to the power of 4, e to the power of 5, e to the power of 6. np.log means log 0, log 1, log 2, log 3, log 4, log 5. Sign means sign of 0, sign of 1, sign of 2, sign of 3, sign of 4, sign of 5. Like this, we can apply the trigonometric functions. We can apply log and exponent functions. So like this, we can apply multiple functions in entire things. So here you can see with respect to some kind of pink color, which is called as warning. Why you got this warning? Because np.log a of 0, log 0 is infinite. Na? Whenever the infinite word has came into picture, it is going to throw an error, warning. There is a infinite word in your data set. Please check that one. It is throwing a warning. This is called as warning. This is not called as an error. Whichever is in the pink color, it is called as warning. You can ignore that one. That is not a problem. Right? That is with Numpy. If you understand Numpy, pandas will be understand, right? If you understand Numpy means pandas will be, because pandas was created, Monday's class is pandas. Pandas was created based on the Numpy plus dictionary. Linked. If you understand Numpy means pandas will be nothing. If you understand pandas means sklearn will be nothing. If you understand sklearn means machine learning, nothing. If you understand machine learning means artificial will be nothing. Just their link only. If you understand properly, everything will be easy.